Have you ever looked up at the night sky and wondered, how did all this get here? You're not alone. For centuries, humans have pondered the mysteries of the cosmos. But then came the Big Bang Theory, the most widely accepted model for the origin of our universe. The Big Bang Theory tells the epic tale of how our universe burst into existence from an extremely hot, dense state about 13.8 billion years ago. Everything we see around us, stars, planets, galaxies, all originated from a point smaller than a pinhead. But how did we get from a tiny speck to the vast expanse of the universe we see today? Buckle up, because we're about to embark on a cosmic journey. From the formation of the first atoms to the birth of galaxies, we'll uncover the secrets of the early universe. Along the way, we'll encounter fascinating concepts like cosmic background radiation, dark matter, and maybe even peek into the mind-bending realm of the multiverse. So get ready to expand your cosmic horizons and have your funny bone tickled, because the Big Bang is not just a scientific theory, it's the ultimate cosmic comedy show. Join me, your cosmic tour guide, as we journey back to the beginning of time and unravel the mysteries of the Big Bang. Imagine a single point in space, infinitesimally small and unimaginably dense, containing all the energy and matter in the entire universe. This is the singularity, the starting point of our cosmic story. Now picture this tiny speck of everything suddenly bursting forth in an explosion of epic proportions. This was the Big Bang, the mother of all explosions, the cosmic event that set the stage for everything we know and love. In the blink of an eye, the universe went from being smaller than an atom to an incomprehensibly vast expanse. Talk about a growth spurt! And just like that, our universe was born, expanding outwards at an incredible rate. This was an expansion on a cosmic scale, with space itself stretching and growing at mind-boggling speeds. As the universe expanded, it also cooled, allowing energy to convert into matter and antimatter. Antimatter is essentially the opposite of matter, and when these two meet, they annihilate each other in a burst of pure energy. It's like a cosmic game of rock, paper, scissors, where matter and antimatter duke it out for supremacy. Thankfully for us, matter won out in the end, leaving us with a universe filled with stars, planets, and all the good stuff that makes life possible. And that's how our universe began its incredible journey. In the first fleeting moments after the Big Bang, the universe was a chaotic soup of elementary particles. Quarks, leptons, bosons, you name it. Quarks began to clump together, forming protons and neutrons, the heavy hitters of the atomic world. Now you might be wondering, where's the light in all of this? Well, hold your horses, because the universe wasn't quite ready for its close-up. In those early days, the universe was still incredibly hot and dense, so any light that was produced was immediately scattered by free electrons. But as the universe continued to expand and cool, those free electrons finally got the memo and started pairing up with protons and neutrons to form atoms, primarily hydrogen and helium. This pivotal moment, about 380,000 years after the Big Bang, is known as recombination. With the formation of atoms, the universe became transparent, allowing light to finally travel freely through space. This first light, emitted billions of years ago, can still be detected today as the cosmic microwave background radiation. So the next time you gaze up at the night sky, remember that you're looking back in time, witnessing the remnants of the Big Bang itself. Now let's talk about expansion. The universe is constantly stretching, like a cosmic balloon being inflated. But here's the kicker. It's not expanding into anything. The universe isn't expanding into some pre-existing space, it's creating space itself as it goes. Imagine you're an ant living on the surface of a balloon. As the balloon expands, the distance between any 2 points on its surface increases. To you, the ant, it would seem like everything is moving away from you, even though you're not moving at all. That's kind of what's happening with the universe. Galaxies aren't flying through space away from us. Rather, the space between them is expanding, carrying them along for the ride. And the farther away a galaxy is, the faster it appears to be moving away from us. This expansion was first observed by astronomer Edwin Hubble in the 1920s, who noticed that the light from distant galaxies was redshifted. This redshift is a direct consequence of the expansion of the universe, and it provided the first concrete evidence for the Big Bang Theory. So the universe is always expanding, and we're just along for the ride. Remember that first light we talked about earlier, the one that finally escaped the universe's primordial fog when atoms formed? Well, that light didn't just disappear into the cosmic abyss. It's still out there, permeating the entire universe as a faint afterglow of the Big Bang, known as the cosmic microwave background radiation, or CMB. Discovered by accident in 1964 by Arno Penzias and Robert Wilson, the CMB is like a cosmic time capsule, providing us with a snapshot of the universe as it was just 380,000 years after the Big Bang. The CMB might be faint, but it's chock full of information about the early universe. By studying its subtle temperature fluctuations, cosmologists have been able to determine the age, composition, and geometry of the universe with remarkable precision. It's a constant reminder of our cosmic origins, a faint but persistent echo of the event that brought us all into existence. Now let's talk about the elements, the building blocks of everything we see and interact with. As Carl Sagan famously said, we are star stuff. But how did we get from a universe filled with mostly hydrogen and helium to the rich diversity of elements we find on Earth and throughout the cosmos? Well, it all started with stars. Stars are born from the gravitational collapse of massive clouds of gas and dust, mostly hydrogen and helium. As this material collapses, it heats up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores. During nuclear fusion, hydrogen atoms are fused together to form helium, releasing a tremendous amount of energy in the process. As stars age, they continue to fuse lighter elements into heavier ones, creating elements like carbon, oxygen, nitrogen, and all the way up to iron. When stars reach the end of their lives, they expel their outer layers into space, seeding the interstellar medium with the elements they've created. From our vantage point on Earth, the Milky Way galaxy may seem like the entire universe, but it's just one of billions upon billions of galaxies scattered throughout the cosmos. Galaxies are vast collections of stars, gas, dust, and dark matter held together by gravity. They come in a variety of shapes and sizes, from majestic spirals like our own Milky Way to massive elliptical galaxies and irregular dwarf galaxies. Think of galaxies as islands in the vast cosmic ocean, each one a unique and intricate ecosystem teeming with stars, planets, and perhaps even life. The formation and evolution of galaxies are complex processes driven by gravity, gas dynamics, and the mysterious influence of dark matter. Galaxies are not randomly scattered throughout the universe, rather, they tend to clump together in clusters and superclusters, forming a vast cosmic web. The study of galaxies and their distribution provides us with valuable clues about the history and evolution of the universe. We've talked about the Big Bang, the expansion of the universe, the formation of stars and galaxies, but there's still a lot we don't know about the cosmos. In fact, most of the universe is made up of stuff we can't even see or interact with directly: dark matter and dark energy. Dark matter is a mysterious substance that doesn't emit, absorb, or reflect light, making it invisible to telescopes. We know it exists because of its gravitational effects on visible matter, like stars and galaxies. Dark energy, on the other hand, is even more enigmatic. It's a hypothetical form of energy that permeates all of space and is thought to be responsible for the accelerating expansion of the universe. Together, dark matter and dark energy make up about 95% of the total energy density of the universe. It's a humbling thought to realize that we're just a small part of a much larger cosmic mystery. Now, if you thought the concept of an expanding universe filled with dark matter and dark energy was mind-boggling, hold on to your hats because things are about to get really weird. Enter the multiverse, the idea that our universe is just one of many universes, potentially infinite in number, each with its own set of physical laws and constants. The multiverse is still a highly speculative idea, but it's gained traction in recent years as a possible explanation for some of the more perplexing aspects of cosmology. Imagine a cosmic bubble bath, with each bubble representing a different universe. Some bubbles might be very similar to ours, while others could be radically different, with different laws of physics, different dimensions, and maybe even different versions of ourselves. While we don't have any direct evidence for the existence of the multiverse, it remains an intriguing possibility. Who knows what wonders and mysteries might lie hidden in those other universes? So there you have it, a whirlwind tour of the Big Bang Theory and its cosmic implications. From the singularity to the multiverse, we've explored some of the most mind-blowing concepts in astrophysics, all while keeping a sense of humor and wonder. But the story of the universe is far from over. New discoveries are being made all the time, pushing the boundaries of our knowledge and challenging our understanding of the cosmos. As we continue to explore the universe with ever more powerful telescopes and sophisticated instruments, we're sure to uncover even more mysteries and wonders. So keep looking up at the night sky and never lose your sense of curiosity and awe. The universe is a vast and mysterious place, full of surprises and delights. After all, it's the only universe we've got.